Okay, 7.4.2. Now that we've established the fact that we can have arcs in circles or pieces of circles, you'll remember back to when we did segment addition postulate back in math in the previous courses, right, when we were dealing with segments. It should be no surprise that there is an arc addition postulate, and it goes something like this. If C lies between B and D on a circle, and the idea of being between means that C is on the circle, somewhere between B and D, then the measure of arc BC, right, which is up here, the measure of arc BC plus the measure of arc CD would be equal to the whole entire thing, right? So just a quick graphic to show something that should be fairly obvious. And again, just a reminder that the measure of these arcs have everything to do with what is the central angle on the inside. I think if I try to move these now, it will not move, but so that's a little bit of a problem. But remember that the measure of the arc is simply the measure of the central angle in here, right? And if we add up angles, we can add up arcs. Let me just try to take that out. Okay. On the other circle, we also have the idea of the midpoint of an arc. And I've created this graphic down here where actually K is always right down the center. Okay, and again, the definition, midpoint of an arc. K is the midpoint of arc HM if and only if, meaning it goes in both directions. The measure of arc HK right here and the measure of arc KM are the same. And remember that the if and only if piece, this piece right here, which is sometimes confusing to people, it simply means that we can go in either direction. We can either say if the measures of the arcs are congruent, then it's a midpoint, or we can say if it's a midpoint, then the arcs are the same. That's what if and only if means. And it's important. It's a, whoops, didn't mean to do that. Let's see, can't get that back. No, okay, that's a flaw. So there we go. Midpoints are there. Okay, arc addition postulate and midpoint of arc.